Hi, everybody. It's great to be here. My name is Mike Biercuk. I'm the CEO and founder of Q-CTRL. And our objective is to make quantum technology useful for the vendors and also useful for the many end users who would be listening to this call as well. Our focus today is a little bit different than the other companies you've heard from, but it's complementary. We build infrastructure software with the aim of delivering useful performance and accelerating the path to quantum advantage. If you like these analogies, we're like the turbocharger to the supercars that are built by all of the different companies that you've heard from today. We build tools for application enhancement that is hardware optimized application modules. We build tools for error robustness and noise-aware compilation. We build tools for hardware stabilization and AI automation. And of course, like many other companies who are active in the field of developing practical quantum error correction, you can read about some of our work in that in IEEE Spectrum that was just published yesterday. And quite importantly, our tools are technology agnostic. We provide everything from the quantum firmware, which touches the control electronics all the way up through compilation and quantum error correction in a way that works across the different modalities that you've heard from today. We're the world's only trusted provider of quantum control solutions and quantum control infrastructure software. We service national laboratories around the world. We have commercial partnerships and commercial relationships with a wide variety of companies, including two that are actually on this call. We sell to academia. We also are very active internally. Overall, we have about 5,000 individual users of our software. Our R&D team has run more than 12 billion jobs on IBM systems as we've developed core technology. We have announced major partnerships already with Rigetti, with IBM, with AWS. We've worked with Rigetti for a number of years, and for what it's worth, we've appeared in a variety of media outlets. The core of our offering to the end users of quantum computing is the realization that quantum computers are exceptionally unstable and exceptionally prone to error. If you do the math, it turns out that these systems, even the absolute best being provided by all the different companies around the world today, are about 24 orders of magnitude more likely to suffer an error in a computation than a conventional system. And this leads to obfuscation of the insights that customers actually want. So if you think about what you should achieve with Grover's search algorithm on the left, when you actually run it on a machine, even at very small scale, this is a 5-qubit algorithm, you get nonsense. You get something that is obfuscated by the noise. But if you run it through our software with actually, in this case, a single line of code, you can have this binary transition that converts the hardware into a system that gives you a useful output. Overall, our contribution is to turn these very well-engineered bare metal hardware servers, the bare metal QPUs, if you will, to use language from the cloud domain, into quantum processing units that give you real insights. Now, we have shown in head-to-head comparisons on real commercial superconducting quantum computers, in this case, up to 9,000x improvements in algorithms using our software, again, in a zero config setting. This allows our customers and our partners to gain insights that otherwise they simply could not get, as per this quote from edtech. The core product offering for end users is a tool called FireOpal. This is previously announced to be forthcoming this year on AWS Bracket, and it is exceptionally simple for the end user. The end user who has developed their own application for either their production workflows or their R&D simply feeds a description of their circuit into our software. Everything else happens in an automated fashion, including the connectivity to the hardware backend. We return to you an answer that has improved utility to you. Now, for anybody here who's an expert, this is all about automated error suppression at the gate level and at the hardware level. It is exceptionally efficient. It's also 200 times cheaper to run than any of the sampling-based approaches because it is deterministic. And the last thing I'm going to say is that if this is not quite you're not quite ready for this, we do offer the best edtech tool in the world for quantum computing. It's called Black Opal, and you can get access to this from our website along with all of our other documentation. So thank you very much.